Hello everyone, my name is Hui from class 1C21. Today, I with my teammates Cường and Tai here, feel very pleased to present to all of you an interesting topic, diabetes detections using decision tree. And our topic today is divided into five main parts. The first part is called inspiration, where we will express our thoughts and motivation for choosing this topic, and I will deliver it to you. Following this, Cường will show you all of the technologies that we use to complete the project in the second part. Move to the third part, the software's operation process, for which Tai is responsible for to mention about the details of code implementation process as well as the key output of it. Moreover, I again will figure out some example of the project's practical applications in real life. And last but not least, the conclusion to sum up all the key points that we have just delivered to you by Cường. Okay, so now let's get to the points. Look at the screen here. We have 5 ideas to answer the question that why did we choose this interesting topic. The first one is aligns with health tech trends. Applying AI in a disease diagnosis is a prominent trend in the rapidly evolving field of health technology, or we can call health tech. This project provides practical insights into the conversions of the medicine and advanced analytics. Next is to reduce the healthcare burden. I believe that an effective diabetes detection model could alleviate the load on the healthcare workers and facilities, especially in resource-constrained areas. Automated early detection enables timely patient support without relying solely on major healthcare assets. And to move on, it also enhances the analytics skills. Building the model requires analyzing influential factors and making decisions about the key features. This develops strong analytical thinking and problem-solving abilities, valuable for future machine learning projects. The fourth one is that this project is potential for advancement. This topic offers room for deeper research and more complex machine learning in healthcare. A well-performing model could lead to the publication opportunities or real-world applications deployment. And finally, it is the practical applications. A successful diabetes detection model could potentially be integrated into clinical settings or healthcare apps, make it a project with tangible real-world impact. So now to move on, I will invite Cường to show to all of you about the technologies used in the project.
Okay, so moving on to the next part regarding the technologies used in the project, we have 5 main points to cover, which is core Python library, visualization library, machine learning library, key data processing, and model evaluation tool. So now let's come to the first point, the core Python libraries. These core Python libraries form the foundations of data processing and preparation steps in the project. By leveraging pandas and NumPy, the code is able to load the dataset, handle missing values, and prepare the data for further analysis and modeling. The OS library is also included as a standard library that can be used for file system operations. Next point is the visualization library. These libraries are used in the provided code to generate insightful plot and graphics to support the data analysis and model evaluations process. By leveraging Matplotlib library and Seaborn, the code is able to visually communicate key findings, such as feature correlations and the decision tree structure. In the next point, the machine learning libraries. Well, in our project, we utilize several key machine learning libraries to enhance our model performance. The sklearn.model selection library was crucial with train test split used to divide the data into training and testing sets. The grid search CV employed the hyperparameter turning to optimize our model. The sklearn.tree library provides a decision tree classifier, which was the main machine learning algorithm we used, and the plot tree, which help us visualize the decision tree structure for better understanding. And additionally, the sklearn matrix library offers various evaluation metrics to assess our model performance comprehensively. Next part is key data processing. Well, in this slide, I will outline the essential step in data pre-processing. Well, we will handle missing value using NumPy where functions. Outliers will be treated using predefined rules. Visual scaling and normalization will ensure the consistent data range. Finally, we will split the data into training and testing sets, allocating 75% of training and 25% of testing sets. And the final point is the model evaluation tools to evaluate the performance of a classification model. We will employ several key tools. A classification report provide insight into precision and recall and F1 score for each class. A confusion matrix visually represents the model correct and incorrect predictions. The ROC curve and the AUC score assess the model ability to distinguish between positive and negative classes. Finally, the feature important analysis has to identify the most influential feature in the model decision-making process. So before going to the next part about the entire process of software operations, well, which will help everyone to gain a deeper understanding of the project we have developed, I will inform you about the next part. So, in time.
Thank you, Cường. And now I will take over the presentation and present about the entire process of software's operations. The first part of the operations is importing the libraries. In this part, we import the essential libraries for the diabetes detection models, such as pandas and NumPy to support the data handling, matplotlib, dotpilot, and Seaborn 8 in visualization. And scikit-learn provides tools for splitting data, building, optimizing, and evaluating the machine learning model. The second part is data processing. In this part, we handle the missing value by replacing zeros in specified columns such as glucose or blood pressure with not a number. It then fills these not a numbers value with the column median to ensure the realistic data distribution. Here, the second part of the data processing is the treat outliers. In this part, we remove the outliers in the diabetes dataset by applying thresholds defined in outlier rules for each column, like pregnancies or blood pressure. Values below the minimum are set to mean value, and values above the maximum are capped at max value. Next is the exploratory data analysis. In this part, we create a heat map to show correlation between features in the diabetes dataset with values displayed and a cold-warm color gradient. As you can see on the screen right here, this is a heat map. And the next is data splitting. In this part, we split features and target. So the first code right here separates the target variable, which is the outcome from features X. The second code splits the data into training and testing sets with 25% for testing, a fixed random seed for reproducibility. And next, we move on to the model development. In this part, there are three subparts. The first one is initial the decision tree model. This code right here initialize and trains a decision tree classifier, which is the DT initial, using the training data, X train and Y train. It then prints the model's accuracy scores on both the training and testing sets, providing insight into its performance on known and unseen data. The next is hyperparameter tuning with grid search CV. This code right here performs hyperparameter tuning on a decision tree model using grid search CV to find the best setting for criterion, max depth, min samples split, and min samples lift. It applies tenfold cross-validation to evaluate each parameter combination and prints the best parameters and the highest accuracy score from the cross-validation results. And the last in this part is final model with best parameters. This code initializes a decision tree classifier DT final with the best parameters found in grid search CV, grid search dot best params. It then trains the fit this optimized model on the training data, X train and Y train for improved performance based on tuned parameters. And now we move on to the next important part is the model evaluation. This part contains 5 small other parts. The first one is the function purpose and input. So in this part, we define the print model evaluation function, which takes 3 inputs: the true labels, which is Y true, predicted labels, which is Y pred, and a dataset name for identifying whether the evaluation is for training or testing data. It initializes the output with a header indicating the dataset being evaluated. The next part is classification report. In this part, the functions generates a detailed classification report using matrix.classification report, which includes precision, recall, F1 score, and support for each class. The third one, we move on to the third one is confusion matrix. This part computes the confusion matrix using matrix.confusion matrix, which shows 2 couples, true and false positives, and as well as true and false negatives. The fourth part is additional metrics. Additional key metrics, such as accuracy and recall, are calculated from the confusion matrix. This matrix provides a concise summary of the model's overall performance. And move on to the last small part of this model evaluation is applying the function. The function is applied to evaluate model's performance on both the training and testing datasets. The predicted labels are generated using the train model, and the print model evaluation function is called to display the evaluation result. Next, we move on to the feature importance analysis. In this part, we calculate the feature importance using the train model, creating a data frame with features and their importance, and print the sorted results. Next is the visualize decision tree. Visualizing the train decision tree, which is DT final, using plot tree, displaying it with features names, class labels, which is yes and no, and limiting the depth to 4 for better readability. So as you can see, this is the decision tree, which is the output. In this tree, we can see the tree structure and split. Each node in the tree represents a decision based on a specific feature. The root node checks if the glucose level is smaller or equal 143.5. If true, it moves left to split by the BMI. And if false, it goes right to split by age and further glucose thresholds. We can also see the entropy and information gain. Each node has an entropy value, indicating data disorder. Lower entropy means the data is more homogeneous. The tree splits to reduce entropy, maximizing information gain to better separate the classes. We can also see the samples and value of the tree. Each node here shows the number of samples it contains and their class distribution. For example, the root node has 576 samples with 371 label yes and 205 no. We can also see the class prediction. At each leaf node, the tree assigns a class, which are yes or no, based on the majority in that node, like 78 yes in the bottom left leaf. So overall, this tree supports early diabetes detection by making interpretable predictions, helping healthcare professionals understand influential factors. And now we can move to the last part, which is the ROC curve. In this part, the code generate and plot the ROC curve, calculating AUC and visualizing the model's true-false positive rates. So overall, the ROC curve is very useful for evaluating the performance of the model and for comparing it with other models in the future. So, and that's all about the software's operation process. To move on, Huy will help me with the next part. Thank you.
Okay, thank you for your presentation part, Tai. And now I will carry on the next part about the real life usage of our project, okay? So the diabetes detection model we have developed has far-reaching practical applications in the field of healthcare. By leveraging the power of decision tree algorithms, we can unlock the valuable insights that support preventive care and clinical decision-making, population health and management, and medical research. About the preventive healthcare, the model's ability to accurately predict individual diabetes risks based on the factor like family history, lifestyle, and health indicators allow us to identify the high-risk individuals. We can then leverage these insights to provide personalized recommendations for diet, exercise, and other lifestyle intervention to prevent or delay the onset of diabetes. Additionally, continuous monitoring of key health metrics can help detect early signs of pre-diabetes and evaluate the effectiveness of preventive measures. Ultimately, this enables the design of comprehensive, tailored the diabetes prevention programs. And secondly, clinical decision support. So as you can see, by equipping healthcare providers with models and predictive outputs, we can enhance the accuracy of diabetes diagnosis. This model's analysis of risk factors can also guide optimized treatment protocol for individual patients. Furthermore, the proactive identification of high-risk patients allow for timely intervention to prevent or mitigate diabetes-related complications. This supports more convenient, more efficient utilization of medical resources for diabetes prevention and management. So move on. The third application of this project is the population health management. At the community level, the decision tree model, can pinpoint demographic segments, geographic areas, or population subgroups with elevated diabetes risks. This empowers the planning of targeted public health initiatives. By monitoring and analyzing the popular level data, we can uncover in the insights about the spread and progression of diabetes within a given community. These data-driven findings can inform the design and the implementation of customized prevention and management programs. Ultimately, the model's evaluative capabilities can assess the impact of such community health intervention and guide future program development. Okay, and last but not least, research insights. The decision tree model's output also provides a valuable insight to direct medical research efforts. Interpreting the model's features importance can help prioritize the most impactful risk factors for further investigation. Oh, and additionally, the data-driven insights generated by the model can inform the creation of evidence-based clinical practice guidelines for diabetes prevention and management. And by analyzing the strengths and limitations of the current model, we can also work towards developing increasingly sophisticated and accurate diabetes risk assessment tools. Finally, the model's risk stratification capabilities can optimize the selection of participation for diabetes-related clinical trials. enhancing the validity and generalizability of research findings. And to conclude all what we have delivered to you, Cường will have me. Okay, Cường, thank you.
Okay. To carry on the last part of our presentation. So as you can see in this modern era, AI has shown its important role in many fields, including healthcare. The AI-based diabetes detection model is a significant advancement in model healthcare. So aiming to alleviate the burden on healthcare systems through early interventions. It also provides valuable learning opportunities for students and researchers. The implementations of the process involve a standard machine learning pipeline focusing on data preprocessing and model development, which an emphasis on optimizing decision tree models using Python tools. This model has a practical application in preventive healthcare by identifying high-risk individuals, assisting doctors in diagnosis, and analyzing community health trends. The projects showcase the successful integration of predictive analytics in healthcare with potential for further development through additional data sources and new machine learning technique. Also, in summary, this project effectively combines advanced technology with healthcare needs, highlighting the importance of early diabetes detection through decision tree modeling and laying the foundations for future advancements. So that is all about our presentation. Thank you all for taking time to listen, and I hope the information and insights that we share have been valuable and beneficial to you. If you have any question or feedback, I would be delighted to hear from you. Once again, thank you for your attention and interest.